want to acknowledge our university community supporters, the University of Iowa's International Programs, and the University of Iowa's Honors Program, and the Stanley UI Foundation Support Organization for their financial support. And I want to especially thank today's special financial sponsors, Bob and Mary Ross, and the Midwest One Bank. It is my pleasure now to introduce Greg Carmichael, who will speak to us today on Post-Paris, What's Next for Climate Actions. Greg Carmichael is the Karl Kammermeyer Professor of Chemical and Biochemical Engineering and the co-director of the Center for Global and Regional Research at the University of Iowa. Greg also serves as the Associate Dean for Graduate Studies and Research for the College of Engineering. Greg is also Director of UI Informatics Initiative. As you can see, he's a very, very busy man. Greg has done extensive research related to air quality and its environmental impacts with over 280 journal publications. And he's a leader in the development and application of chemical transport models at scales ranging from local to global. Greg serves as the chair of the Scientific Advisory Group for the World Meteorological Organization's Global Atmospheric Watch Urban Meteorology and Environmental Project. That's quite a mouthful. Which is focused on building capacity worldwide to improve air quality forecasts and related services. In addition to serving on a number of prestigious environmental panels and boards, Greg is an active instructor and advisor who has mentored 33 MS and 31 PhD students during his tenure. Please join me in welcoming Greg Carmichael.
Thank you. It's certainly my pleasure to be here today and to talk with you about post-Paris, so what's next, with a big question mark. I think it's certainly in the news, very appropriate. When I accepted this, I forgot that this was also the UN week, so lots of interesting developments taking place during this week that are relevant. So today I want to kind of probe this issue, talk a little bit about the overview of the Paris Accord, what is so significant about this accord. It is very, very important point in international cooperation in what I think is one of society's biggest challenges, certainly the biggest environmental challenge we've ever faced in terms of climate change. I'd like to talk then a little bit about just some snippets about what's happened since Paris. And just to give you a little bit of flavor of what's happening internationally, and talk a little bit about some of the activities that I'm engaged with the World Meteorological Organization. Talk about some of the challenges, opportunities and challenges. The cities are extremely important, so a lot of activity. I think of cities from many perspectives, but certainly from environmental perspectives, are on the front lines in terms where society and politics and actions are taking place first. And I'll talk a little bit about air pollution and the climate links, because these are very intimately related topics. And we're very fortunate to have Wang Wei with us visiting. I'll introduce him later. But he's a leader with the Ministry of Environmental Protection in China. And then we'll just then have some opportunities to collectively look forward. I don't have any magic answers here, but there's lots of opportunities and challenges moving forward. Okay, so let's talk a little bit. I know this is very small to see in terms of the Paris Climate Agreement, but this is a historical agreement. We've been working on getting the international community together to agree collectively to take action to reduce greenhouse gases for a long time. More than 20 years now. And Paris was the first time that we were able to actually bring countries together. It was a clever sort of negotiation. 196 countries have agreed to this. 160 have now actually formally approved it in their home countries. And it was really this collective activity to recognize that human contribution to greenhouse gases is moving us in a very dangerous direction, and that to avoid these most serious outcomes of climate change, we need to reduce the growth of temperature change to 2 degrees or lower. And in order to do that, the countries then voluntarily set targets for the next decade or so. And that was part of it. It's a voluntary contribution. And the developed countries recognize the need to take a larger share of this burden in the short term than the developing countries. And it then had all sorts, it has all sorts of mechanisms, $100 billion available by 2020 to invest in developing countries to move towards their mitigation strategies. And then some other protections in terms of recognizing the importance of forestry, and both in terms of growing trees takes carbon dioxide out of the atmosphere, so that's a plus on the side of reducing greenhouse gas concentrations. And then again, this mechanism of trying to advance technology as quickly as possible to move towards a cleaner and less energy intensive development pathway. So it's a wonderful component. Again, it's the intentions are voluntary, which is very, very key to it. It's voluntary, and I think it's important that we talk about this in the context of what the U.S. may or may not do moving forward. It's a voluntary component. Each country sets their own intentions. It can be modified and reviewed at 5-year intervals. So the U.S., you can see in the chart there, this is the current percent of countries' share of current greenhouse gas emissions. So the U.S. is 20%. China has overtaken us in terms of absolute values in terms of 23%. EU and India are large elements, large contributions. So the U.S. in its commitment is to, it took a baseline of 2005, and that's the baseline for, you can choose your baseline, and committing to reduce its greenhouse gas emissions by 26 to 28% by 2025, with a hope of getting to 17% by 2020. Europe took a larger aspiration and intention. You can see 40% there. So that all of the developed countries are talking about reductions in their greenhouse gas emissions in terms of absolute amounts. The developing countries have taken a different approach. So you can, China there, it's committed to reduce its energy intensity, so the amount of CO2 emitted per unit of economic development or energy used to drive the economy, by 60 to 69%. Okay. And to increase its non-fossil fuel component of its primary energy consumption of 20%. So these are, and I'll show you in the next slide, that so these are efforts to reduce the growth in emissions in the short term. In the China's case, it has a goal of maximizing its CO2 emissions by 2030. And you can see India took has a lower intention, reducing its energy intensity by about half of what China is doing. So each country, again, 194 countries have put their intentions on board. 160 countries have gone back and had those verified by whatever process they need to put into to get the country to absolutely commit to their intentions. So here, this diagram shows, again, from the U.S. perspective, again, we're committed, at least our intention, as stated in the Paris Accord, is to reduce our greenhouse gas emissions in 2030 by about 26 to 28%, with the intention for it to be 28% as opposed to 26%. You can see that our greenhouse gas emissions peaked in about 2005, and so we're talking about absolute reductions in CO2 emissions. To date, we're now at 2017. We've reduced national emissions by about 7% so far since. So we're in the right trajectory. And you can see China's a great example of, so their intention is to slow their growth. You can see a very rapid growth of CO2 emissions. And you can see that their commitments is to slow the rate of growth, which is extremely important, but again, hoping to maximize its peak values in 2030. And I can say that since the Paris Accord, since our recent presidential election, China has used the opportunity to take a little bolder position internationally, and they're moving towards maximizing their greenhouse gas emissions before 2030. So they're trying to move more progressively. So this is just a wonderful activity because, again, up until this point in time, we haven't had any agreement internationally to reduce emissions. And it's because it's very, very complicated, right? The developed countries have been able to do what they wanted to do in the growth of their economies, not had to pay attention to CO2 emissions. Now we're reducing greenhouse gas emissions, but then in the developing countries to say that don't do what we did, but be smarter and cleaner in your growth forward. It's a difficult argument to make. But now we have this agreement. And what does it mean? So here's the INDCs is the trajectory that we're on if people behave according to their intentions. And you can't see it here. I mean, so here, can you see? So without, I'm going to leave and come back, but this is the pathway we would be on without the Paris Accord. Okay. So from a scientific community, I was very worried when the Paris Accord came out because it is a baby step. Okay. And so many in the scientific community were saying it's not good enough. You can see that it's really just moving us down the path a little bit. And where we need to be out in 2050 are along those lines there, the blue and the green, if we're going to really avoid what we think are the most dangerous responses to a change of global temperature of 2 degrees. But it is a step in the right direction, and I think all the intentions are with this agreement that as we move along that curve and relook at things in 2025 and beyond, we're going to see that we're going to make advances much quicker than we admitted to. So I think most of us feel that only good things will happen as we move along this path. Okay. So the good news of Paris is that it brings everybody together. It recognizes kind of the tension between developed and developing countries, and it puts us on a pathway to do better things in the future to take action. Okay, so that's kind of setting the stage of what the heck is the Paris Agreement, okay? And now I'll talk a little bit about what's next for U.S. climate actions, and I think it's really a question mark. We only know, what has been stated. Recently, last week, still you hear snippets of are we going to back out or not, but we won't know. And certainly we heard from the French president yesterday that, and the Paris Accord doesn't allow for any renegotiation. It's a voluntary activity. You're committed. So, you're not going to make a better deal because you're making a deal with yourself. So, and so if we pull out, we did agree to it. If we pull out, we would join Syria and Nicaragua. Okay. So even North Korea is signed on. So so we are really an outlier in this regard. Okay, let's move forward a little bit and talk about what's going on in terms of climate change. I think it's very appropriate just to take the last couple weeks as a benchmark. What's gone on in the last couple weeks is just a whole bunch of extreme weather. Okay, so there's the unrelenting heat wave that's taken place on the West Coast. We've had unprecedented floods in Bangladesh and Nepal, and certainly very recently and still in play are the extremely strong hurricane season that we have. We have Irma, we have Harvey, we have ones that are approaching. These are very, very hard and very strong and very impactful. So lots of extreme weather. And in addition, unprecedented and growing amounts of biomass burning that's occurring. This is a slide from earlier in September. You can see the smoke coming from the Northwest fires, and I think anybody that was in Iowa City or the Midwest at that point in time could taste it, and you could certainly see it in the beautiful sunrises and sunsets that occur when we have so much smoke in the atmosphere. And so all of these extreme weather events and their kind of increased intensity are we're having much more confidence now that we can relate those to climate change. We have the science has advanced rapidly in terms of our ability to attribute extreme events to climate change. That's in part because our understanding of how to do that is better. We have better models and we have better observing systems. And so with for example, in the hurricanes, as the sea temperature increases, and we have that documented, the oceans are warmer. As these hurricanes form naturally over the oceans, these tropical depressions, as they sit over warmer water, and as their movement is blocked because the Arctic is heating faster than the equator, and so that changes the jet stream distribution. So we have more time for these storms to sit over warmer water and build naturally, but they intensify. So we understand that, and so with increased confidence, these sorts of things are what's expected from a climate change perspective, and similar things can be talked about from wildfires, and we know that the intensity of rain is shifting as we warm the environment, and we expect more frequent intense rains and less light rain conditions. So all of these things are very much involved with the fact that, at least pointing in the direction that climate change is real, it's happening, and probably happening at a faster rate than we anticipated, even when we were negotiating 2 degrees from a Paris Accord perspective. So moving forward, so what's happening? So certainly many things are happening. I'm going to take just a few minutes here and talk about some of the things that are happening to try to get climate change out in front of the community and people, and actions being taken. As indicated, one of my roles is I co-direct the Center for Global and Regional Environmental Research, and Joel Bolcom is head of our outreach activities. And we have taken the lead over the last 7 years to develop an Iowa climate statement. So each year we pick a topic, and this year with a recently released, and I think there's copies out at the back if anyone wants this. And this year's statement, we take one aspect, one topic, and this is it's not just the heat, it's the humidity, and talk about humidity and what we know about how it's been increasing in Iowa. So we relate it to Iowa in terms of its impact. This increased humidity is occurring in all seasons, and it has a pretty profound impact on, we know high humidity in Iowa, not good for us and not good for the plants, not good for our pets. And so this statement talks about that. The remarkable thing is that this statement is developed by the scientific community in Iowa. I think this year we had 193 individuals sign this from 40 different institutions, and then it goes out in press releases and those sorts of things. So it's one way of connecting kind of what do we know about climate change and what does it mean to us, and then it talks about what are some of the things we can do to the importance of moving forward and doing our best to reduce greenhouse gas emissions. And so while the federal government in the U.S. Is deciding what it wants to do in climate change, the good news is, in reality, in many examples, the train has left the station in the sense that communities, states, and other countries recognize that the path to a lower greenhouse gas emission is a pathway to a higher sustainability and a better pathway to be on than the one we're on. And so many cities, I think 38 states have action plans that are advancing. Many cities, and Iowa City is a great example. We recently adopted essentially the same commitments that the U.S. made to the Paris Accord, with an additional commitment of a large reduction, I think 70 or 80% by 2050, which goes beyond what the U.S. committed to. So lots of positive things happening. So I want to take just a minute and talk about some of the things that we're doing as introduced. I actually chair the Scientific Steering Committee for the WMO, which is a scientific agency within the UN organization. And I chair all of their environmental programs, the Scientific Steering Committee. And so we're doing quite a bit related to greenhouse gases. And one of the things we're doing is this program, this Integrated Global Greenhouse Gas Information System. And, is that?
Since the Industrial Revolution, humans have been adding carbon dioxide and other greenhouse gases to the atmosphere at a much faster rate than Earth's natural cycle can remove them, causing atmospheric concentrations of greenhouse gases to rise. As a result, our global climate is changing. To reduce emissions and strengthen sinks that remove greenhouse gases from the atmosphere, countries need a clear picture of their national emissions, trends, and sources.
Maybe a little bit more.
Until now, we've relied on indirect estimates of national emissions based on national data and statistics. For example, by counting how many cars are on the road or how many barrels of oil are consumed, we can estimate emissions from these sources. But adding up all these calculations only produces estimates. While global levels of greenhouse gases have been tracked for many years, advances in science and technology now make it possible to directly measure atmospheric concentrations at the national level. This is done using networks of high-resolution monitoring instruments. Before the gases have become globally mixed, their spatial patterns can be mapped in great detail. Because gases like carbon dioxide exist in different forms, or isotopes, each of which is emitted by a different kind of natural or man-made source, scientists can identify where they came from. Advanced models can simulate how winds and rain dispersed the gases after they were emitted. By running these models backwards, scientists can identify and quantify the natural and human emission sources, as well as the natural sinks. These results make it possible to confirm and improve the emissions estimates, providing complementary information on national greenhouse gas emissions. Thanks to these developments, governments can now have access to more accurate data to gauge their progress and to report their national emissions figures. National figures are then added together to provide a clearer global picture of humanity's emissions trends.
Okay, so this program that this IG§IS system is a combination of observations and modeling, and the goal is really to support the post-Paris actions and to really help governments. We have these commitments. We want to work with them and provide techniques to actually verify for them the success that they're having, not as a way of holding them accountable, but really a way for them to get credit for in a way that's uniformly determined by a high scientifically regarded organization. And so this is a very exciting and new component. We're working with at the highest level, but also with individual countries to pilot this. So I talked about the Paris Accord has this $100 billion funds. They're actually distributing money out of that, and we're working, for example, with Morocco in terms of using this system for their verification purposes. A lot of the developing countries are already making use of this. Another thing that WMO does in this activity is that we are responsible for the global observing network for greenhouse gases. And this is very important because this has to be done with very high precision and quality if we're going to be able to put observations together from all over the world to talk about what's happening in terms of trends of CO2. Coming back to the US perspective, under the current administration, much of the infrastructure for this global observing system actually comes from the US. It's from NOAA, under the Commerce Department, which also includes the Weather Service under that. And currently, anything with the name climate in it is under attack from a budget perspective. And already NOAA and the main laboratory for the greenhouse gases in Boulder, this program has had already not a projected cut, but already a 20% cut in its budget for this year. And so it's this sort of kind of attitude or responses. I mean, everybody, but it is an example of just some of the infrastructure that is very, very important to the global community, and that the U.S. makes a tremendous contribution to is being degraded a little bit. And more elements are certainly under threat under this climate adverse science environment that at least exists federally today. I want to transition now to the urban environments. Urban environments are absolutely critical. More than half of our population now lives in urban environments, and it's only going to get a larger percentage moving forward. Many of those are sitting in coastal areas and very, very susceptible to flooding, poor air quality, sea level rise, extreme heat and cold stresses, and just a whole bunch of public health problems. From an urban environment, 70% of total greenhouse gas emissions are in the urban environments. So that's why the urban areas are so critical in terms of kind of the forefront of climate action plans. Another activity at the UN level is the Habitat series, Habitat 3. This is a series of conferences that's held only every 20 years. They take on big issues for the next coming decades and develop agendas. And the Habitat one, this was held in Ecuador last October, and WMO and I participated in helping shape this new urban agenda in terms of sustainable development from both all sorts of things, but from an environment and climate perspective. Just to point out, there's air pollution alone. There's 7 million deaths per year that are avoidable. And in China alone, 1.2 million are attributed directly to air pollution. And that will lead us in just a minute to hearing from my guest here. And so there's lots of activity that the U.S. can be proud of. This is going back to 1980 in terms of how we can balance economic development, population growth, and still, have reduced exposure to air pollutants, but also have a reduction of CO2 or the reduction of the growth rate. So there are ways to bend the curves. We're on those trajectories, and things like the Paris Accord and an understanding that climate change is real, it's happening now, and the need for actions are now, as opposed to the longer we wait, the harder it's going to be, and the more damage we're going to be committed to. There are ways to do it, and the good news is there are ways moving forward. Now I want to take, I'm really pleased to be able to transition this, and let's hear from not only my perspective, but we can hear from a perspective from China. I'm very happy to have visiting me Dr. Wang Wei. He's with the Ministry of Environmental Protection, and he's with the Chinese National Environmental Monitoring Center. Now, China has, they're forecasting air quality. They have, I told you there's $1.2 million people dying each year due to air pollution alone in China. It's a very, very serious problem. The government is under great pressure by the citizens, but also self-pressure to really try to improve that situation. So China has, I think, the most progressive air pollution forecasting system. They use the air quality forecasting system in ways that are unprecedented because they need to take actions right away to protect their citizens. And the government is highly, highly committed to do that. And so it's very much a pleasure. He's here visiting me for a couple weeks to learn some of the things, to share information, to learn some of the techniques that we're involved with that might help improve their forecasting system. So please, let's welcome.
Thank you and good afternoon. I didn't notice the importance of this meeting until I come here today. So it's a great honor to be here to give you such a brief speech. So this is basically what we do and who we are. So here is our center is called the National Center for Environmental Quality Forecasting. So it's a new division. It's founded in 2013. It's directly affiliated to the Ministry of Environmental Protection in China. So our center is in charge of the national air quality focus. You can see the results on the corner of the slides. There is a focusing result by our numerical model. So our task is also included to release the public information to the public. For example, we know that there is a pollution case in the next few days, then we will send our focusing result to the public. Then also we will send our result to the government to help them to make the policy. So you can see the other slides. Sorry, let me see. Here. So there is another slide here. Is the high performance supercomputer in our base floor. So our numerical model is run on this kind of computer. So this is the framework of our focusing system. We use the meteorological data input, and also we have this kind of emission inventory, and also have lots of observations from the ground-based sites. So then we use this kind of WRF. It's a very famous numerical model for the meteorological field focus. Then we have this smoke model for the inventory simulation. Then we use 4 very famous air quality numerical model. One is the NACUMS. This is developed by China. The other 3 are all developed here in America. It's very widely used models in the world. Then we have this kind of air quality index in China and different concentrations of different pollutants. So here is an example of our result. You can see that the 4 model use the same emission inventory and the same meteorological data inputs. But due to the difference of the model, we have different results. By combining these results together, then we will have a more realistic result for the next few days. And now this is a very interesting figure. I will tell you why. Because you can see that there is a 4 figure means 4 years. It's 2013 to 2016. And this line is the different cities in the North China Plain, where is maybe the most polluted area in China. Beijing is just located in this area. And from the bottom, we can see that here is the months from January to December. So this is the observational data of PM2.5. And the PM2.5 is a particle that is very harmful to the human's health. And it is a cause of the haze and the decline of the visibility. So we can see that in different seasons, we can see that the highest concentration often occurs in the winter. But you can compare the 4 figure. We can see that in the past 4 years, there are great decline in the spring, summer, and autumn. We can see that the color becomes to green. It means the low level of concentration. But still, we can find that there is a relatively high concentration of PM2.5 in the winter. So this is something that we really cares about. So greater improvement in summer, spring, and autumn, but not so many changes in the winter. We can see that there are still some red colors in the January and the December. So we must figure out how to deal with this kind of pollution period. So this is a successful case in just last winter in December 2016. So our job is to do the air quality focus. It's just like the people's eyes. We see the pollution is coming. Then we tell the government to make some strategies. Then they cut down the emission. This is the baseline. So here at the 13th December, it's just the end of the last pollutant case. But then we just found there will be a next pollutant case in the next few days. In 3 days later, then our focus length is just 7 days. So for example, we can see that things happened 7 days later. But for this case, we just break this limitation. We found that due to the bad meteorological field, that we have this kind of very serious pollutant case, maybe in the next few days and maybe end in the 21st. So then on the December the 14th, it's a very good day. It is very sunny. Then the government has already begun to do something about this kind of situation. Then emergency reaction has been called by the MEP, the Ministry of Environmental Protection. Then the minister itself has also attended the meeting. Then they decide to send the alert and cut the emission immediately. So it is decided very fast. Then on the December the 15th, the policies has been sent to different provinces. So we can see that here is a big area of the North China Plain. We can see that here it has a very high concentration of PM2.5, and these areas are all the upwind area of Beijing or Tianjin, this kind of city. So, and after this decision has been made and the policy is sent to different provinces, and then on the December the 16th, the AQI, the observational data, AQI in Beijing has already exceeded 200, which means our focusing is very accurate. And then at December the 22nd, it is end of this case. So after our result has sent to the government, and the government called a different level of pollutant alert to different provinces. We can see that here is the suggestions to send to the local government by MEP. So here is the map of the different level of alert. We can see that there is a 3 level, the yellow one, the orange one, and the red one. The red one is the highest one. So we can see that all these countries need to do something during this kind of pollutant case. So this slide, sorry, it's all written in Chinese character, but I can tell you that in this area, so many policies has been made. Ask all the factories to do something, for example, to cut down your emission or to cut down your workload into 30 or 50% during this area. So many places, including all the cities in this area. And the government also send people directly to the local itself. For example, some people have been sent to the factory to see if it is indeed closed according to the policy. And often there is some case, for example, the factory closed during the day, but at night they just work as usual. So all the people have sent to make sure these policies have been carried out successfully. And then, according to our results, here the blue line is the focusing result from our system, and the red one is the observational data. We can see that during this period, due to the efforts of the government and this kind of policy, there is a huge gap between our simulation and the observation, which means the great effort and the great success of our control. So this is yeah. Sorry. So these are the works done in the last winter. I just show you one of the cases that we do very successfully. So from this October 2016 to this year's spring, so there are more than 20 emergency actions in China, North China plant, and the minister itself attended 16 of them, and 11. Send alert information into public for maybe 11 times, and for the 6th time we send this unique urgent policies to different provinces to cut down the emissions. So this intensity of the policies is unified, and tons of work has been done in the last winter. And for this winter, maybe when I go back to China, the heating season will already begin. So a lot of work will ahead of me. So also our task is also including to support the big international conference. For example, this 2014 APEC meeting, Obama was there. So our results also served for this kind of conference to make sure the air quality is okay during that time. Also for the G20 is 2016 in Hangzhou, China, in the eastern part of China. We also send our people to there and using our result to make sure this air quality is okay and serve for the people and the government. These are our staff and showing on the television. These are the news using our results. So here is members from all over the country of the air quality focus. It's the effort of the whole country. So. And finally, at last, these are the 2 pictures I took here yesterday. Even though this is a very ordinary view to you, but to me it's also very beautiful. It's on the riverside. So the air is very clean and the water is also very clean. I think I think a lot. Really? Really? I think there is a great difference between China and America, but we have so much in common. Though there is a great improvement in the air quality in China now, but there are still many works for us to do. Hope through our effort we can have clean air and clean water, and just like you did in the last century. So this is all I think about it yesterday. So it's nice to share with you. Thank you.
Yeah, thank you. Yeah. Yeah, so he talked about, China's under great pressure from an air pollution perspective. They're spending lots of money, but like for the G20, they're getting used to having these large international events with blue skies, and I don't want to know what will happen to your budget if you miss a forecast one of these days. So, yeah. So I think that that kind of gives you a kind of an overview of kind of lots of good things happening post-Paris, lots of challenges. So I'll stop there. Thank you.
The first question is how to check the accuracy of the mathematical models. Greg, do you want to take that?
Yeah, that's a great question. So all these models are complicated and for a lot of different reasons, but all of the models there's an operational evaluation of the models. So the models their predictions are tested against observations. That's the simplest. But all aspects of not only the concentration, say, of pollutants, but also whether the weather was predicted correctly or not, consistent with the observations of wind. So there's a very comprehensive component of evaluation. So just like air quality, we do the same for weather, and then climate models are evaluated the same way over longer timescales. Yep.
Okay. There's a follow-up question related to the CO2 that's already in the atmosphere. Of the CO2 already in the atmosphere, what is the percentage that is of U.S. origin, of Chinese origin? And the second part of the question is, what are the comparable CO2 emissions of the U.S. and China per person?
Okay, so starting with the first one, it's not. So the simple answer is, when I release a molecule of CO2 today, about half of it will be in the atmosphere 100 years from now, and about 10% will be in the atmosphere 700 years from now. So to the first order, we put in 20% of CO2 in the atmosphere. It doesn't matter, the U.S. puts in 20%, China puts in 24%. That CO2 just gets mixed around and uniformly. So above our head here, on average, it's going to be, from a global perspective, it's going to be 20% U.S., 24% China, and et cetera. So that molecule released today is here for a long time, and it gets well mixed in the atmosphere. On a per capita, you can do the math. We have among the highest per capita emissions in the U.S. It's about 5 tons of CO2 per person. China, I think, is below 0.2 or 0.3. So the U.S.'s average is 5. What do you think the average is in Iowa per capita emission of CO2? Higher or lower than the U.S. average? Yeah, a lot higher, like 3 times higher. Yeah. All the agriculture, we're pretty energy intensive with not many people, and we have pretty energy intensive components.
Thank you, Greg. Isn't U.S. reduction based in part on methane replacement of coal? And then the following question is, and doesn't the extraction, distribution, and leaky storage of methane make it as bad as coal?
Yeah, so the good news is that there has been a rapid short-term conversion from coal to methane, and that's price-driven, and that price driving point has been the fracking. It's the availability of methane, and it's good news from the climate perspective, because even though methane is a very powerful greenhouse gas, the overall emissions per energy delivered is still lower, and it's much less polluting also. It is indeed the fact that there are problems with methane extraction. Some of it is leakage, but some of it is also air pollutants related to that. We're largely the problem that can be done cleanly. It's largely a problem that's not very well regulated, the various fracking operations. So, but the net effect is still positive. We're not leaking so much that we're not getting an overall benefit from switching to methane. But again, that comes up again from a U.S. energy policy perspective. Because of the pricing component, there really isn't, in my opinion, there's no way you're going to increase the use of coal in the normal modes of application of coal under the current situations where the availability of methane and the way that other states are moving towards greenhouse gas action plans. So.
Thank you. This question has to do with natural causes. Is there any part of the climate change that is because of natural causes, for example, ice age?
Sure. I mean, so we know that lots of natural causes. We know volcanoes. We know the intensity of the sun, and all of those aspects have been evaluated very carefully, are taken into account, and we are able to model those in a representative way for prior climates. And so we're aware of those. They're documented, and the fact is they don't add up to driving the today's climate. So.
Thank you. There's another question about another major economy in the world. Japan is one of the largest economies in the world today. Why is their emission so low?
Yeah, they had a very strong commitment to nuclear. And in the long term, as we think forward how we're going to get on the path to deliver our energy and do it in a way that's clean. I mean, you go back before Fukushima, nuclear was rising in its kind of strategy component. It certainly took a pause after Fukushima. So I mean, nuclear is the reason that that they have been relatively low in terms of their overall emissions.
This question is with regard to China. What are the policies or laws that have reduced emissions? What are the policies or laws that have reduced emissions in China?
Okay. I see. I think there's a standard of the emission for the factory of different industry, but I don't think there is any laws regarding to that part. I'm not quite familiar with that area, and I think for the long term, I just show it in that case, it's a short-term policy. For example, we know a pollutant episode is ahead, then we take this short-term policies to cut down the emissions. But besides that, there are so many long-term policies. For example, you can see that in the past 4 years, there is a great improvement in the other 3 seasons. That is caused by the long-term policies to improve the environment. So that's all I know. Sorry, I don't know if I already answered your question. Thank you.
Yeah, but they have a very aggressive, every 5-year plan has an element to it that addresses very significantly emission reduction. So certainly things like, in the big cities, the car standards for new cars are moving forward very rapidly to the European standards, for example. So, yeah. Oh, it is and will have a major impact. Yeah, I mean, certainly those renewable energy sources, they're not absolutely clean in terms of a greenhouse gas footprint, but they're extremely lower than we have. And so, yeah, I mean, that's, my own advocation for policy is to electrify everything and to drive all our electrical power from, solar and from renewable sources. Electrification gets rid of, get rid of the solid fuels altogether, and move that direction. But certainly, those forms of generation are the path forward. Yep.
I'm sorry, we have to conclude the questions at this point. I want to give a big thank you to Greg Carmichael as well as Dr. Wang Wei for joining us today. I also like to thank our sponsors, the University of Iowa's International Programs, the University of Iowa's Honors Program, and the Stanley UI Foundation Support Organization for their generous support. We also thank today's special financial sponsors, Bob and Mary Ross and the Midwest One Bank, and we thank City Channel 4 for making our programs available to the viewing audiences. Greg and Dr. Wang, as a small token of our appreciation, we present you with the coveted Iowa City Foreign Relations Council mug. Thank you again very much for joining us. We are adjourned. Thank you.